Hello, my name is Casey Shibler and I'm doing a reassessment video on the Circuits 2 with Capacitors standard. As you can see, we have a circuit and there's a voltmeter, 2 batteries, and 4 resistors and 2 compasses. As you were reading in part A of this question, it asked me to basically write conventional current equations for this loop and this loop. Let's see here. Basically, we're following the loop rule. Ignore this. I have the current going in the wrong direction. The current's supposed to be going this way. I have 3V minus I3 times R2 plus R3 equals I4 minus R4. 3V equals I3, R2 plus R3 minus I2, R1. They all add up to equal 0 according to the loop rule. You can also derive that I2 plus I3 is going to equal I4. And you can also say that I1 equals I4 as well. And if you actually look at all of this, there's I4 equals I1. All of this should equal I4 and I1. Alrighty. I also have I3 equals 2/5 I2, because whenever we plug in our resistant values, we have 20 plus 30, that's 50. 20 over 50 is equal to 2 over 5. Then if I3 plus I2 equals I4, then you can actually substitute this value in I2 to get 7 over 2 halves. I3 equals I4, which I forgot to write my I, sorry. Alrighty, so that concurs with my equations that I made, and then we can begin part B. As you can see, part B says to basically find the compass deflection. It gives me the degree of compass 1, and then it asks me to sketch it. So I have already solved for the current, which will help me find the compass deflection, because instead of using the magnetic field, I can use I equals mu naught over 2, typically times A, but in this case it's just going to be 1. So I have tan theta over mu naught 2 equals I over I earth. I need to rearrange it to find I earth, which I do, and I plug in my 0.073 value, which is what they gave me for the current running through R1, over tan 3 degrees, which is what the first compass deflects. And through rearranging my equation, I then plug in the value I just got into my tan inverse I over I earth to give me 4.1969 northwest. As you can see, I have my deflection. The reason why this is going to point northwest is because the current is running this way, and it will point there. Alrighty, part C then asked for me to find the E2. It gave me all of these values except for Q, which is just the charge. I is actually the current that I derived earlier, so that gives me 0.029A. I equals Q nav, which is what I'm going to use to find the electric field, because velocity is equal to the mobility times the electric field. I plug in my values and I get 126. Part B asked me, is the electric field 1 and resistor 1 larger or smaller than E2? The amp value for E2, or I'm sorry, for resistor 2 is actually larger than for that of R1, so that's actually going to result in a larger electric field. So it can be said that ER1 is larger than R2. So therefore, that concludes that problem. What is the length of R2? Well, I can use V equals I over R, because V being the potential energy will give me my volts. I then use that into the potential energy difference is equal to electric field times the length, which reverses to give me E delta V over L. So I have 126 because it's asking me for resistor 2. What is the length of that one? Equals 0.58, which I just found, over length, which gives me my length, which I left in meters. Then asked for part F, what does the voltmeter read, and include the sign. So for that, I have V equals IR. I plug in to get my 0.58 again. Now I started off with 3 volts, so therefore I have delta V is equal to 3 volts minus 0.58, which gives me 2.4. Now due to the due to the batteries being hooked up to the negative side of the voltmeter, as you can see here, that's going to result into having a negative potential. Sorry to go through this problem so fast. It's very large. I appreciate your time. Thank you. This concludes my video.